Greetings to the authority. This is Abhigan Pal, a team member of Team Revolution, and we had worked upon this carbon eater prototype. Despite of the COVID restriction, the half of the team is at particular place and half of the team is on other place. We not let this shortcoming gets into the way for the development of prototype. We had attended the webinar of ION, which motivated us and build the teamwork into this project, and we had extensively worked upon this prototype. So the prototype is divided into two phases. First is the detection, the software phase, which is developed by half of the team, and second is the working model. The exact implementation of the whole thing is done by half of the team. So after this, you're going to be listening to Abhilash Gaurav, the team leader of Carbon Eater, and he'll be explaining how the software, the detection, how exactly the setup will be implemented into the roads, and he'll give you the setup, the software which he had developed will set instruction to the carbon eater which have been hanging on to the roads and highway to get switched on and capture the carbon in the air.
Hey there everyone, my name is Abhilash Gaurav. In this video, I'm gonna explain how our detection part for our prototype carbon eater will work. So it's a simple code in Python. We use OpenCV module to use a normal laptop camera as our source of detection. While using this code, one can easily capture the real-time detection of the vehicles. If the limit of the vehicle reaches up to certain limit, then it will send the instruction for turning on the carbon eater. So let's see. So it is processing. So here is the red line. It indicates a terminating line. So when a car passes from this, passes from this line, it increases the count by 1. So by this method, it increases the count up to a certain limit and sends the instruction to the carbon eater to be turned on. As you see here, the number of count is increasing 1 by 1. So it already sent the command to turn on the carbon eater.
So as we had seen that the software will detect the count of the vehicle, and if a particular count exceed a particular count value, then the carbon eater which is been set up onto the highways that get initiated, and the carbon eater system will get switched on. As there are multiple carbon eater into the market, but no one just automate the process. We have automate the process because the value of carbon dioxide or the carbon particles into the air is not constant every time. So right now I will explain out the different components of the carbon eater. First of all, we had used a transformer. This transformer just step up the voltage, because as I mentioned that we have also used electrical plates which will coagulate the particles. Then over there we had also used capacitors. These capacitors are as we know that capacitor stores high value of charge, and they are there to just charge those electrical plates. Over there we had used the power supply from the luminous battery which I had. This battery provides the DC supply, AC supply, and this AC supplies get transformed to this carbon eater, and it's been powered by. So after this we had used this hair dryer. Since we are into the prototype phase, and because of the tight budget, we're not able to get the exact fan, but the hair dryer fan will act as the same fan which will be there into the prototype. Right now I'll explain now what is inside the carbon eater. So first of all, at the initial we had a metal plate which is also electrically charged. That will capture most of the carbon particles, soot particle, or any big chunks. Then we have two electrical plates. These electrical plates are highly charged. This will be charged by this transformer and the capacitor. As we have studied the concept of chemistry, that if any charged particles gets in contact with the electrical field, it loses its charge and gets coagulated. And it is the same principle which is used by chimneys. We had used the same concept to capture the carbon into the air. Second, we have specially designed charcoal activated 2 carbon filters that will just, if any air particles or carbon particles gets left over, those will be captured by this by this nanocarbon charcoal activated filters. So this is the whole setup, And after this, I'll just switch on and show you the exact demonstration. Okay, so we had artificially tried to create some smoke into the environment, and this hair dryer will suit up the soot particles and the carbon particles from this smoke generator to the carburetor. First layer will capture, second layer will capture, third layer will also capture the carbon particles, and if that is also left, then we have those carbon charcoal activated filters. So I'll just switch on the carbon particles and show you the results. Okay, so we had taken up this, and since the electrical plates had captured, I can also see the black formation, the carbon and the soot particle formation on those metal plates. They have coagulated the particles up to a large extent, and this initial electrical plates also get some soot particles get captured because of the electrical field. So this is a whole prototype, and this is absolutely functioning. We had also tested this into a whole environment of smoke, and within 15 minutes this had captured all the smoke particles, and it has been extensively working because the sole principle behind this whole setup is those electrical precipitator, the concept of coagulation of colloidal particles, and the concept is very well functioning. We had only explored this, and by use of all these components we are able to achieve this successful. The whole ambition of the project is to deploy these onto the highways where the count of vehicle is directly proportional to the pollution. So if vehicles are more, this will automatically gets on, and it will automate the process of carbon eating into the environment and hence clean the environment. This carbon eater just need a monthly maintenance, and after this can capture the whole set of, and if these are implemented over a series, then they can also had a significant result into the environment conservation. That was the ambition before starting the project, and we had built upon this. We are great. We would like to thank that there's ION community to getting us into the prototype phase. We are very excited for this prototype to get to your jury members. Thank you and have a spectacular day from Team Revolution.